Alright, now our project for the Aiyehum project sponsored by IEEE, the LRCDS robot is ready. Let's take a look at it. Alright, so are you guys ready to give a demo about the project?
This is an indigenously designed innovative robo for the purpose of detection of cracks in Indian Broadway rail lines. We got a motivation from mainly the recent accidents which occurred in Odisha, which were mainly due to lack of maintenance and also in some cases due to antisocial elements. Now,
so Mr. Scientist Gourav, are we ready to go?
Yeah, sure. So here we turn on the robot, and so here I go. I just plug this alligator clip onto the battery. This power on the microprocessor and the thing starts. So the bot will start by first calibrating the LDR, which you can see over here. It is there on this side as well as that side. So we will be showing you for just the one side, and so it starts. To calibrate the robot, we first have to lift the robot. So here we go. We lift the side, and here the thing starts.
So first it calibrated itself without the light, and now it's calibrating itself with the light, right?
Yeah, that's what is happening.
Alright, cool.
So you can see the LED turned on and it's calibrating, and beforehand it calibrated without turning on.
Alright, that's cool. And now the calibration ends, right?
Yeah.
Alright, so now that the calibration is over, our bot is ready to move. Let's see our bot in action. And just because we give this low PWM signals, the bot is going slow. So, and now there is a crack, and it detects the crack, and yeah, the bot stops. Alright, now it's supposed to send an SMS, right? Let's expect the SMS. That's the GSM kit working on this. So, where is your mobile, dude? Let's wait for the SMS. Alright. So, one new message, and we see that. So the new message from the bot, and that reads the latitude and the longitude values of the crack, and that's it. There goes the project. And that's Gourav, Saha and Vigneshwar, along with SSR. Okay, so now let's listen to a complete technical explanation of our LRCDS project. Over to Gourav, Saha.
So, as it was said before, that this project is to find cracks in railway tracks. So now we go on to the construction of it with a brief algorithm of what is happening. So we can see that first of all, the microprocessor used. You can see the microprocessor. This is the Arduino Uno microprocessor. We have basically used this I shouldn't call it a microprocessor, it's an augmented microprocessor, because we just need to plug into the computer and we can just program. Actually we have used it so that the programming and all is easier, rather than we didn't go for much of interfacing.
Yeah, so the actual microprocessor used here is Atmega 328, right?
Yeah, that's right, Atmega 328. You can see the microprocessor over here. Alright, this is equipped with mainly 13 digital pins and 6 analog pins. Now we go on to the algorithm of the bot. First, we are as we told before that it uses LDR and a LED arrangement to detect cracks in railway balls. So we have it on both sides, this side as well as on the other side. You can see, and so basically before starting the bot, we told that we are doing some kind of calibration, right? So this LDR is connected across a potential divider, and when the light falls on it, the resistance changes and the voltage across the potential divider changes. What we mean by calibration is this voltage, the voltage when the crack is present and the crack is not present may change every day, dependent upon the ambient light present in the surroundings. So rather than keeping the voltage constant, the threshold voltage constant, we calibrate every time the boss starts. So that is the basic calibration. That's why we are doing the calibration over here. Rather than using a LED and a LDR, we could have used a IR also, but since we thought of using laser before, so LED was the LED, LDR arrangement was the best. So first it calibrates, after that it moves on to, after that the boss starts moving. So this is the basic algorithm. The microprocessor will basically turn on the motor, the boss starts moving. If any crack is detected, that is a voltage difference will be created, which will be detected by the microprocessor by these analog pins over here. Both the sides go, the voltage of both the sides go onto the microprocessor. If after that, what happens is, if some crack is detected, we can see the onboard GPS over here. This GPS is basically
the onboard GPS is connected to the Arduino, right?
Yeah, of course the GPS is connected to the Arduino. It is doing a serial communication. The serial communication pins are over here. The last one, if you can see, those are the two serial communication pins. One is to transmit, another to receive. The same is occurring over here. It is transmitting at the speed of, receiving at the speed of 9600 bps. So that is the GPS receiver, and that is basically the IC and the circuitry. The main GPS receiver is over here, as you can see. This GPS receiver follows the NMEA convention. So after it detects the coordinate of the crack, railway crack. After that, through this onboard GSM receiver, it transmits the coordinate of the crack to a particular mobile as it is given in the program. If you want to see, you can see the Vodafone SIM card, which is placed below the GSM receiver, and that's all for the explanation of the robot.
Alright, so finally this is what the robot does. It just calibrates itself, it moves on the track, and once it detects the crack, it transmits the GPS coordinates from the GPS and to the Arduino, wherein the Arduino will transmit it through the GSM to any mobile number. So, and that's our LRCDS project for Aiyehum. Thank you.